Bismillahirrahmanirrahim. We'll continue the remaining part of the first visualization lecture or part, and then we will move on to the second session. So I think we covered already the line plot, okay? And we said that the line plot is used when we want to see the relationship between two numerical variables, okay? We also have another type of plot, which is called the scatter plot, which we also use for plotting the relationship between two numerical variables. But here, as you see, there is no connections between the dots that we put on the curve, on the figure, or the plot. Okay. In the line plot, there is a line that's connecting every two consecutive points. Okay, but in the scatter plot, we don't have this. Okay, and do you have any idea why? First, each dot here represents one individual. Okay, so on the x-axis, these are the individuals that we are dealing with, and on the y-axis, this is the value for each individual. But we have one dot for each, which is the case here also. Okay, but here we don't connect the dots. Okay, and then
because the dots are too close to each other, no relation. It's the net sequences.
It's not only the case that they are close to each other, because we might also have points here that are close to each other in the line plot. But the issue here is that there is no sequential order of the values on the x-axis. Okay, there is no meaning of the sequential order. Okay, so here, for example, in the line plot on the left, you'll see that this is the year. Okay, so the year, it's like we are measuring something over years. So each year, we measure the value, and the next year we measure the value again and again and so on. Okay, so there is the sequential notion of the variable here. But here there's no such notion. Okay, here is just data that we collected for each individual, which is the number of movies here. We got the average per movie, which we will discuss, inshallah, in the demo. So let's see the demo, and we get back to when we use line plots and when we use the scatter plot. Okay, so this is the data set that we have. I think we saw it before. We have for each actor the total gross of the movies that he was involved in, the number of movies, the average per movie, average gross per movie, the top movie, and the gross, which is the income for that top movie. Now, if I want to see the relationship between the number of movies and the total income, okay, so we will use the scatter plot to get a plot like this. So this is I think the plot that we saw in the previous slide. Here on the x-axis we have the number of movies, and on the y-axis we have the total income or total gross. So what is the meaning of each point? So for example, this point, that means that there is an individual in the data, okay, that has like maybe 52 or 53 movies, right? And the total income for it is like very close to 4,000. Okay, but there are no sequential relationship between these dots. It's just the fact that some of them are close to each other and some of them are far, but there is no relationship between them. Okay, between the values on the x-axis. Okay, each is indicating one individual. Now, yes.
Can you please repeat what the meaning for
Each dot?
Exactly. Yeah.
Okay.
The relation of number of movies and the total.
Okay, so we didn't look at the relationship yet, but the meaning of each point, or the value of each point, is taken from one row in the data. Okay, so there is one row in the data, one individual, one movie, one actor in our case, in which, or for which there are, this actor actually was involved in like maybe 78 movies. Okay, and for these 78 movies, the income was something like maybe 3,100. Okay, so for each individual there is a dot on the on that plot, but we don't connect them, because connection means each dot has a next dot, and that dot has a next dot, and so on. There is no such notion here. Okay, they are not sequentially ordered, so we should not connect them. But still, we can look at the data and get some insights. So what do you think about this plot? Is there any relationship we can think of between the number of movies and the total gross? Do you see any trend here? It might, of course, you should not expect that it will be perfect, right? But do you see any trend here?
About the number of movies close to 2,523.
Is there a relation between the number of movies and the total? Can we say that when the number of movies increases, something happens with the total gross or something? Or it's not always the case, yes, but I'm talking about the general trend. Do you see a general trend here? It seems to me that the general trend is something like this, right? It's when the number of movies increases, generally the total gross increases, right? Of course, it's not the case always. It's not perfect, but the general trend is that. So we can look at it that way. Let's see another scatter plot. Now we will plot the relation between number of movies and the average per movie. The problem with the plot that we have here is that we cannot compare between actors, okay, based on the total gross, right? Because if I am involved in more movies, I will get more. The total gross will increase, right? So it's more fair probably to compare based on the average gross. Okay, so whatever the number of movies that I was involved in, what is the average gross for each? That can be easily comparable. So let's plot this relation. Notice, of course, that the scatter method is different from the plot method. The plot method draws a line plot. Okay, scatter of course draws a scatter plot, and as the plot method, it takes two variables. Okay, and both are numerical, as we did in the line plot. Now, what do you see in this figure?
That the number of movies decreased whenever the number of movies increased.
Yes.
Average per movies decreased.
Yes, here it is more clear, right? It's more clear than the previous one that when the number of movies decreases, when the number of movies increases, the average per movie decrease. Okay, so it seems like there is a negative relationship here. Okay, right. Before we get into what could be the reason behind this, or what's the meaning of this, let's look at this point. Does it look normal relative to the others? No, right? It's like it's very, very different from others, right? We call such points outliers. Very good. Okay, so this point is called an outlier because it doesn't seem that it goes with the trend of the other points. Okay, so what does it mean to have a point like this? So this means that with very few number of movies, this actor, of course, this point belongs to one actor, right? So that means that with very few number of movies here, which I don't, maybe very few, maybe 5 or 6, this actor had on average, I think 400, or maybe this is 450 million per movie on average. So let's look to see which actor actually is that. So we can do that with where, right? Remember, where selects the rows. So if we get all the rows that are above 400, it's only one, right? Based on this plot, we will get who is that actor. So it turned out that this actor was involved in 7 movies. And if you look at the top movie, you will find that it's one of the very popular series, which is Star Wars. Okay, and that actually gives us an intuition behind why this is an outlier. So this actor, it seems like all the 7 movies that he was involved in were actually in that series, which was very popular. So that's why the average of his movies, which was only in this series, was much higher than the others. Now let's look closer to the rest of the data. Okay, so we'll just ignore the ones that are very low. Okay, and we get all the ones that that are above 10 in terms of number of movies. Okay, so we'll just remove now the outlier, and let's look at the other part and look at the scatter plot with the remaining data. Okay, so this is similar to this, except that we remove the outlier. Okay, now it is more clear that, as we said, as the number of movies increases, the total gross, the average gross decreases. Any idea why that could happen? Imagine that you are an actor, you play more movies. Should the average income for the movies that you play increases as you play more or decreases? Of course, it seems like decreases here, right? Any idea why? Yes. Yes. When you act in many more plays, of course, not all of them will be as popular as the others, right? Many of them, as you increase the number of movies, right? The time is limited, right? As you increase the number of movies, maybe you add more movies that are not of high popularity, okay? And thus the income is not as good as the others. Okay, so whenever you add more, you play in more movies, the average will increase. Of course, the total will increase. Your total gross will increase, but the average per movie will decrease, and that can be the reason why this trend is. Okay. Now you saw the scatter plot and you saw the line plot. Let's think about when we should use this versus the other. Okay. Any questions? Okay. So getting back to the slides. Now, when to use a line versus scatter plot? As we said, the line plots is for sequential data. So if your x-axis has an order, the x-axis has an order, then probably you should use the line plot. And when also the differences in the y-axis, the sequential differences in the y-axis are meaningful. What does that mean? When I plot the values, when I have the values on the x-axis, okay, for each value I have the y value, right? Okay, for two sequential x values, is there a meaning for the difference between the two y values? If that's the case, then the line difference, the line plot is making sense here, okay? Because the difference, sequential difference, has a meaning. Okay, in the plot, when we have the number of movies and the average, if you order the number of movies, there is no meaning of the difference between the two y values. Okay, because the reason actually is that the values on the x-axis are not sequential. Okay, we don't care about the sequence, the order of the values on the x-axis. Okay, if that's the case, then the scatter plot will be better. Yes. Let me just say this, and we'll take your comment. And this is also one of the very important points, the difference between the line plot and the scatter plot. In the line plot, each x value will have just one y value. Okay, you will not find it repeated. Okay? But for the scatter plot, it might happen that for one x value, we have more than one y value. Because it's not sequential, it can happen that for two individuals, they have the same x value, but of course they can have two different y values. In this case, of course, scatter plot makes more sense. Yes?
Okay, well, which one of those conditions is
all of them, okay, all of them apply on the line plot data.
Okay, the scatter plot.
The scatter plot, okay, none of these. Okay, so on the scatter plot that we saw, the x-axis has no order, has no sequential order. Okay, and we didn't take a value when the number of movies is 20, and then we take another value when the number of movies is 21, and then we have 22 and so on. We didn't do that, right? So the values on the x-axis doesn't have a sequential meaning. Also, of course, the difference in y values has no meaning. And as we saw, it can happen if we get back to the curves here. You can see that for the same number of movies, we have here, for example, we have 3 different averages. Why is that?
Not that they did them, but the average is different.
Yes, because these belong to 3 different individuals, right? Each individual might have different average. Although they have the same, they acted in the same number of movies, okay, not same movies, same number of movies, but they have different y values. In that case, line plot doesn't make any sense. Okay, we are not in the line plot because we connect the sequential dots. We have a sequence of values. Here we don't have that sequence. Okay. Usually, in the line plot, usually it's not always the case, but usually the x-axis is time or distance. And of course, you see that this is sequential. So as time goes, we measure the values. Okay. As the distance increases, we measure the values and so on. But for scatter plots, it's used for non-sequential data, and usually we use scatter plots to look for associations between variables. Okay. As we saw in the previous 2 plots, we saw the association between the number of movies and the average income. Okay. And you can, of course, later in the course, we can measure something that will indicate numerically the association between these 2 values, these 2 variables. Any questions? Yes.
Can we say that we have a one-to-one relationship in case of line plot?
In the line plot, each value in the x-axis has one y value, but it's not the opposite. One value might have 2 x values. It's okay. And you might have something like this. Okay, so for the y value, you have 2 x values. Okay, so you cannot say 1 to 1. It's only from the direction from x to y. Okay, good point. Any other questions? Okay, with that, we are done with the first part of visualization. Now we will move to the second part. Okay, so we are done with line plots and scatter plots. Now we'll move on to bar charts and histograms, which I think are more interesting than line and scatter plots. Let's see. First, a quick summary of some terminologies that we used. Individuals are those whose features are measured or recorded. Variable is a feature or an attribute. Of course, individuals in a table are rows or columns, are rows, and variables are the columns. And a variable has different values, and that's why it's called a variable. Values can be numerical or categorical, and each individual has exactly one value of the variable. Okay. Remember that the line plots and scatter plots, they need 2 numerical variables. Okay, they cannot work with categorical variables. Okay. Now we will move on to categorical data and see how we will visualize them. So the first and easiest way of visualizing categorical data is the bar charts. So in a bar chart, we have in one dimension, we have, remember that now we are focusing on categorical data. Okay, what do you mean by categorical data? Or feature like the color. Okay, it has unique individual values. Okay, specific values. So here we have the names of movies on one dimension, and on the other dimension we have the age or how old this movie is. Okay, and in a bar chart we have a bar for each individual value of the categorical variable. Okay, and the length of the length of the bar indicates that value, which is the age in our case. Okay, let's see a demo to show how we how can we plot such graph. So that's the second notebook for the visualization session. So we are still in the movies table or database, and we will just take here the first, just to focus more, we'll just take the first 10 rows of that table. The table has actually 200 rows. We'll just focus on the 10 for now, on the first 10 for now. Now what are we doing here? So we are taking the gross adjusted. So what is the gross adjusted first? So if you look at this table, you will see the gross. The gross is the total income from all the movies. Sorry, here we are talking about movies. So the gross is the total income for that movie. Okay? Now, we cannot fairly compare between the income of movies across time because the ticket price, of course, changes over time, right? So it's not fair to compare the income for a movie that is 50 years old with the income of a movie that was just released last year. So the column that's called gross adjusted tries to adjust the ticket price so that we can compare across years. Okay? So that's actually the column that we are more interested in because that's now comparable across years. So what are we doing here? We take this column and divide by 1 million. So we'll just convert it into millions and we keep just 3 digits. Are you following with me? Okay. Then we add this to the table with column method. Now the table has the millions column. Let's see if we just plotted the relation between the year and the millions, which is the income for that movie, as a line plot. Okay, so we'll get something like this. So that's the year of the movie. Okay, and that's the income. Okay, does that make any sense? Doesn't seem to, because that's it's the years. We are not measuring the same gross for the same movie or something like that. So it doesn't make any sense to use line plot here. The years here are not sequential, okay, in that context. So it's better to see the relationship or some relationship as a bar chart. So let's, instead of plotting the year, we want to compare between the movies. Okay, so we want to see the relationship between the movie and to compare between movies using over the gross. So what we will do is to use the bar chart method. Here it's called bar H. Okay, and in a moment you will know why we added H. So we added H here because we will draw it horizontally. Okay, so the bar H method takes 2 variables. Okay, one of them, the first one, is numerical or categorical? Categorical. Okay, and the second one is of course numerical. Now bar H, because it's horizontal bar chart, then it puts the first variable on the y-axis, and on the x-axis the other variable. Okay, so now the length of the bar is indicating the actual income. Okay. Now you see them ordered somehow, right? Okay, that's not by default. It's by default the method takes whatever order in the table is. Okay, so they were actually ordered by the gross. So that's why the bar chart here was nicely plotted. Okay, if you look at the plot that we saw here on the slide, that's not visually nice, right? Okay, because it's really hard to compare between these movies that way. So what should we do? So we sort them first, okay, and then we use the bar chart plot to plot them. Okay, any question about the bar chart? So that was, I think you saw that before already, or you are familiar at least with bar chart. Let's see if we remove this H, what will happen? So what do you expect? Yeah, it will be vertically. Okay, so it will be something like this. What's the problem with that? Yeah, it's very hard to see. Okay, so that's why the horizontal one makes more sense here. Notice also that the width of the bars are equal, right? So you see the bars here, all of them are equal in terms of the width. Of course, they are different in terms of the length. Okay, are you with us? Okay, they are equal in terms of they are different in terms of the length, of course, because the length indicates the value, right? But they are equal in terms of the width. Okay, keep that in mind, because when we talk about histograms, you will see that in a different way. Okay, now back to the slides. Now we'll talk about what we call categorical distribution. Okay, so we saw how to plot the categorical values. Okay, we use the bar chart. Now, if I want to visualize a distribution of categorical variable, first, what do you mean by a distribution? So a distribution gives us for each different value, for each individual value of the categorical variable, how many times it appears in the data set. Okay, we call that the count, sometimes we call it the frequency of the individuals that have this value. So that's what we call a distribution. Okay, so you can imagine a distribution for each value of the categorical variable. We have a count, how many times that value appeared in the data set. If we do that, if we have this, then we can use it in a plot to see how the distribution is for that categorical variable. So let's see a demo here. We will switch a bit to another data set, which is, actually this is not a, is it the same? Yeah, it's the same, okay, but we will focus on this column, which is the studio or the producer. Okay, let's think about that as the producing company that produced this movie. Now, if we look at the top 200 movies over the years, maybe one company has, or one producer has more than one movie in that top list, right? It can happen. Some might have so many movies, which means that they actually produce so many popular movies, okay? And some might not have that many. So we want to see the distribution of the producers in this data set. How can we do that? We have to do it in two steps. We have to find the counts first. We have to find the frequencies first. Okay? Then, when we get the frequencies, we can use the bar chart to plot these frequencies. So, for now, we only need to look at the studio column. We don't need anything else, right? Because we are focusing on the distribution of that variable. right? So we only select the studio column. Then, in order to get the frequencies, we use the group method. We use the group method. So what the group method is doing is to count for each unique individual value. It counts how many times it appeared in the data set. Okay? And adds a new column called count. It adds a new column called count to the data set. So if we do this, remember the studios is a table of one column. Now, when we group, now studio distribution has how many columns? Two, right? The original column and the count column. Okay, so we expect that now we will see, for example, that this producer, Colombia, has 9 movies. It appeared 9 times in the data set. Okay, Fox has 24, and so on. Now we can see the distribution. Before the grouping, we don't have the counts, so we don't have the distribution. We cannot plot the distribution. Okay, so plotting the distribution needs the counts first, and we can do that using the group method. Then we can plot them. Now, if I get the sum of the counts here, what do you expect? So if I get the count column and sum the values of the count, the number of rows, right? The total sum of the counts should be the number of rows, right? So in our case, the number of rows is 200, so we would expect that the sum will give us 200. Okay, any question about that? Okay, now we can plot the bar chart. If we look at it now, this will give us the distribution. So the bar H method, if you notice in the previous demo, it took 2 arguments, right? 2 variables, right? Because we want the categorical variable and the numerical variable, right? Remember, bar chart, we have to have one as categorical and the other must be numerical, right? So we need both. What happens when we just give one? Where is the other? Says what? It is there, but we didn't give it. So it seems like by default, it takes all the others as the numerical variables that we want to plot. Okay, so by default, it takes the categorical variable and considers the others as the numerical variables. So here is the chart. Now this is a categorical distribution, right? Because the values are frequencies, are counts. It looks like a normal bar chart, right? So it's very similar to what we saw already. So it is a normal bar chart, but that's a distribution just because the values are frequencies over the entire data set. Right, what's the problem with a plot like that? Not sorted. Okay, very good. So it's very hard to see a comparison between the movies. Yes.
But if I have one and one numerical column,
That's a good question.
so here automatically it's default.
Okay, so what happened is that I think we will probably discuss it next time. And we saw something like that, I think, before in the previous lecture or previous 2 lectures before. It will do what we call overlaid plots. It will do all of them on the same plot. Okay? But here, because we have just one more, it just has one variable. Okay? Now, as you said, it is not sorted, so it's better to sort it. So we'll sort based on the counts, and then do the bar chart. So we'll have something like this. Now this is much simpler to compare than the previous one. Okay? Now you can see that there are maybe 3 or 4 or 5 companies, producers, who produced really very popular, very good movies, and the others are scattered over the other producers. Okay? Any question about bar charts and using them to plot categorical values, and also using them to plot categorical distributions? Any questions? Okay, next, which will be next time, we will talk about numerical distributions. So here we talked about distributions of categorical variable, right? Now, before you leave, if I want to have a distribution of numerical variable, how would that look like? So we got the distribution of a categorical variable, right? How we count the number of appearances of each individual value. If I have a numerical variable, it will be a histogram, yes. What are the individual values here? This will be ranges, yes. So this will be ranges, okay, or intervals, we call them bins, okay? So we need to divide the numerical axis into bins, and we count the number of instances or individuals in each bin, and then we plot it, and in that case we call it a histogram, and that's what we will detail inshallah next time. Thank you.